Hello everyone, welcome to Akshar IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Today we are going to discuss about the concept of polynomials. So very important concept. Polynomials is a topic from algebra. Polynomials is a topic from algebra. Now let us see what is polynomial, because you already aware of it. What is term, what is constant, what is variable, what is the term, expression, algebraic expression, like that. Now let us continue that one. So polynomial is nothing but is an algebraic expression. Polynomial is nothing but an algebraic expression involving variables. An algebraic expression involving variables with non-negative integral powers. This is very important. So an algebraic expression involving variables with non-negative integral powers is called polynomial. That means what? What is non-negative integral powers? So whatever the algebraic expression you have taken, that algebraic expression containing some variables, right? That variable should have non-negative integral powers. Integrals are nothing but integers. That means their exponents of the variables. That means the exponents of the variables must be positive integers with 0. Nothing but non-negative integers. Non-negative integers means positive integers with 0. Okay? And their exponents cannot be, or their powers cannot be fractional form. That means not a rational number. Only non-negative integers we have to take. Let us see some of the examples which are being polynomials, which are not a polynomial. Let us see. Let us see that algebraic expression which can be polynomial or not. I am taking an examples, and polynomial or not, we need to decide according to the definition. Now I am giving the polynomial as x cube plus 3x squared minus 7. According to the definition, it is an algebraic expression. Yes, algebraic expression only. Algebraic expression means involving variables. Variables are there, it is algebraic expression. And involving variables with non-negative integer powers. Variables means x. What is the variable in this expression? X. Here first term is x, second term also x. Okay na? Now their exponents, their powers must be non-negative integers. Yes, 3 is non-negative integer, 2 also non-negative integer. Yes, it is a polynomial. Okay na? Now let us take one more example, that is x square minus x power 3 by 2 plus 4. It is also an algebraic expression. While you are observing first one, first term having a positive integer, but second term is not an integer. According to the definition, it must be integer, nothing else. We are not able to take any real numbers or imaginary numbers as their powers. Only we should take the positive integers or non-negative integers. Okay na? Now here 3 by 2 is not an integer, so it cannot be a polynomial. It cannot be a polynomial. Next example, root 2 x plus 4, root 2x. Now check variable x. X means x to the power of 1. 1 is a positive integer, it can be a polynomial. Now root x plus 4. Root x means what? Root x means x to the power of 1 by 2 plus 4. Root x means x to the power of 1 by 2. But the power is not in a integer, so it cannot be a polynomial. Okay na? Now let us see that. X cube plus 1 by x squared. Is it a polynomial? check the variable. Variable having exponent 3. Here also exponent 2. 3 and 2 are positive integers only. So can it be a polynomial? But it is not a polynomial because the variable is in denominator. When you take to the numerator, it will be x to the power of minus 2. It will be x to the power of minus 2. That means it is having the negative integer as its power. So it is also cannot be a polynomial. Now when you look at it, wherever the power is in rational number, it cannot be polynomial. If the power, that means if the x is represented in square root to cube root, it is also cannot be a polynomial. Or if the x is in denominator also, it is not a polynomial. I hope you will understand what is polynomial and what is not a polynomial. Okay. Now let us discuss about the types of polynomials. The polynomials mainly divided into two types. First one based on terms. Based on terms. Second one based on degree. Based on degree. Okay. Let us see the polynomials based on term. So based on terms, we are having some polynomials like monomial, binomial, binomial, trinomial, and multinomial. Yeah. So let us discuss about the types of polynomials based on the terms. So based on the terms, there are mainly four types: monomial, binomial, trinomial, and multinomial. So mono means single. Monomial is nothing but a polynomial contains only one term. Only one term is called monomial. A polynomial contains two terms. Exactly two terms is called binomial. Exactly two terms is binomial. And trinomial. A polynomial contains exactly three terms. Three terms is called trinomial. And what is multinomial? Multinomial is nothing but two or more than two terms. Two or more than two terms. That means binomial also we can consider as a multinomial. Trinomial also we can consider as a multinomial. Clear? So monomial, binomial, trinomial, and multinomial. Now coming to the based on degree. Based on degree, before going to discuss about the types of polynomials based on degree, let us discuss about a degree of a term and a degree of an expression. Okay, na? So let us discuss about the degree of a term and degree of an expression. Yes, let us see. First, degree of a term. Degree of a term. So degree of a term is nothing but sum of all exponents of a term. Sum of all exponents of a term is called its degree. For example, x cube y square z. So in this term we are having three different type of variables. X is having the exponent is 3 and y exponent is 2, z exponent is 1, not there anything is 1. So sum of the exponents will be the degree of this term. Sum of the exponents will be the degree of its term. For example, I am writing 3 cube x power 4 y power 6. Now try to check the degree of the exponent. So 3, 4, 6. 3 exponent is 3, x exponent is 4, y exponent is 6. But we are not going to take 3 as its degree because we are identifying the degree based on the variable, not on the constant. Constant exponent we should not take. Only the variables exponent we should take. So 4 plus 6 will be 10. 10 is the degree of this term. Okay? So sum of the exponents or sum of the exponents of a variables of a term is called its degree. Okay? Next, degree of expression. Degree of an expression. So let us take an expression like combination of terms is called an expression, right? Now I am taking that 3x cube minus 4x power 5 plus 6x minus 7. So while you're taking this is 1, 2, 3, 4, 4 terms are there. Now let us try to find the degree for each and every term. First term degree is 3, only variable exponent we should take. Second one degree 5, third one degree 1, last one degree x is not there, becomes degree is 0. Now among these numbers, what is the highest value? The highest value is 5. 5 is the degree. Degree of this expression is 5. Okay, na? Degree of a term is nothing but sum of all exponents of the variables. But degree of the term, degree of the expression is taken as highest power term. Highest power of the term in the expression is called as degree. Okay, na? Right. Now coming to the based on degree, we are having some different type of polynomials like linear polynomial, quadratic polynomial, linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, and we are having constant polynomial and zero polynomial also. Okay, na? So first linear polynomial. Linear polynomial is nothing but degree of a polynomial must be 1. Degree of a polynomial is 1 is called linear polynomial. Degree 2 polynomial is called quadratic polynomial. Degree 3 polynomial is called cubic polynomial. Degree 4 is called biquadratic. Constant polynomial means degree 0. Constant polynomial contains only the numbers. Here see 7 having the degree 0. Here x is having a degree 1. Here x is having a degree 5. Here degree 3. Okay, na? So the constants having a degree 0. So the numbers constant we can take it as a 0 degree polynomial. Sorry, constant polynomial degree as 0. Now what is 0 polynomial? 0 polynomial degree cannot be defined. 0 polynomial degree is not defined. Then what is 0 polynomial, sir? All the coefficients of a polynomial become 0. For example, if you take like a quadratic polynomial 3x square, for example, see x square plus x plus 5, x square plus x plus 0. And while you are writing it is 0x square, 0 into x square, 0 into x plus 0. This is the 0 polynomial example. Because x square coefficient 0, x coefficient 0, constant also 0. Means all are zeros. 0 plus 0 plus 0, 0 only. 0 polynomial is nothing but all the coefficients of a polynomial become 0 is called 0 polynomial. Okay, now? Right. So we discussed about what is a polynomial and the types of polynomials based on the degree and based on the terms, and the degree of a polynomial we have discussed. Now let us go through the 0 of the polynomial. It is not the type of a polynomial. It is just 0 of the polynomial. Yeah, 0 polynomial means 0 of the polynomial. 0 of the polynomial is having another name, root of the polynomial. Having another name, root of the polynomial. Let us see. For example, if you take any polynomial, whether it is degree 1, degree 2, degree 3, whatever it may be, if you take a polynomial, for certain value, the value of the polynomial becomes 0. Such value is called 0 of the polynomial or root of the polynomial. For example, let me take to the example here. For example, I am taking like 3x minus 6. 3x minus 6 is a linear polynomial because it's degree 1. 3x minus 6 is a linear polynomial because it's degree 1. Now, in the place of variable x, if I wanted to write 1, 3 ones are 3, 3 minus 6. 3 minus 6 is nothing but minus 3 is not equal to 0. Now, in the place of x, if I take 2, 3 2s are 6, 6 minus 6, 0. So I got the answer 0 when I substitute 2. Therefore, 2 is called 0 of the polynomial. 2 is called 0 of the polynomial. Clear? So 0 of the polynomial or root of the polynomial is nothing but for certain value or for any value the given polynomial becomes 0. That value is called 0 of the polynomial or root of the polynomial. Okay now? Yeah, let us go through the concept based questions. Before going to addition and subtractions, let us go through the concept based questions. Yeah, practice sheet 1. Let us see here. Yeah, first question is given that x square plus x. What is the first question? X square plus x is dash polynomial. Actually, it is having two polynomials, means two terms. We can say it is a binomial. But go through the options. Options are given like quadratic, cubic, linear, biquadratic. That means based on the degree it is asking. The options are given as based on its degree. So, what is the degree of the first term? Degree of the first term is 2. Degree of the second term is 1. So, degree of this entire expression is 2. Second degree polynomial. Second degree polynomial is nothing but a quadratic polynomial. The question is for quadratic polynomial. Okay now? Now let us move on to the question number 2. The second question is given that the literal factor. So before that, let us discuss about the factors. For example, I am having a term like 3x square y. 3x square y having 3 is a number, numerical, x is a variable, y is also a variable. 3 is a numerical, x is a value, or means variable, y is also a variable. We can call variables as literals also, numbers as numericals. Okay na? Now here 3 will be the numerical factor. 3 will be the numerical factor. And what about these variables? Variables are called literal factors. Literal factors. Now let us coming to the question once. The question is given that 9p square qr. 9p square qr. Literal factors. Literal factors means the variables involving here p, q, r. These are literal factors of the given polynomial. Okay now? Let us go through the problem number 3. The question 3 is asking about the numerical factor this time. Numerical factor. Numerical means number. What is the number is involving here? 5. So, the easy answer is 5 for numerical factor of the given question. Now, question number 4. That is, which of the following are like terms? I think you are already aware of like terms, nothing but the terms which are containing the same variables with same exponents. Like terms means same variables with same exponents. Same variables with same exponents. Variables means letters. They are called like terms. Now coming through the options, first option 8ab square comma ab square. See the first option 8ab square ab square. Here the variables are ab. Here also ab. Now second one b square, here b square, a b square, a b square. Yes, it is a like term. Same variables with same exponent. Now coming to the second one, a square b, x square a. First term is a b as variables, second term is x and y as variables. So they are unlike terms, not like terms. Third one also like that only. Yeah. Let us go through the question number 5. The degree of the monomial. Here the monomial is given. Let us find the degree. Monomial means single term, one term monomial, one term polynomial. 7x square y cube z power 4. 7x square y cube z power 4. I told you already, degree of a term is nothing but sum of the exponents of the variables. Sum of exponents. 2 plus 3 plus 4. So 2 plus 3, 5 plus 4, 9. 9 is the degree of this monomial. Sum of the exponents of the variables in the term is called its degree. Okay now? Yeah. Now let us move on to the next problem. Degree of the polynomial. Again, sixth question you can do it because fifth one and sixth one having a same model. So let us go through the problem number 7. The seventh one is given the number of terms in binomial. As a definition, we know binomial means how many number of terms? Only two terms. Two-termed polynomial is called binomial. So your option will be 2. Seventh one option will be 2. 2 is nothing but binomial. Two-termed polynomial is called binomial. Now eighth question. Which of the following is trinomial? Trinomial means was three-termed polynomial. You can check and identify the answer in the textbook. Let us go to the problem number 9. The zero of the polynomial. Yes, it is important. Ninth question is zero of the polynomial 2x minus 3. Zero polynomial different, zero of the polynomial. Zero of the polynomial means root of the polynomial. Okay, let us find the zero. To find zero, let us try to equate to 0. Now, minus 3 transpose itself becomes plus 3. X is equal to 2 multiply transpose divides. So, x value 3 by 2. Therefore, 3 by 2 is 0 of the polynomial. 3 by 2 is the 0 of the polynomial. Okay now. Because when you substitute x value 3 by 2 in the given equation, it will get the answer 0. Let us move on to the question number 10. The 10th one is given that, one second. Yeah, 10th question, degree of quadratic polynomial. See here, what is the degree of quadratic polynomial? 2. So, degree of quadratic polynomial is 2. Now, 11th question, degree of zero polynomial. I told you here, degree of zero polynomial is not defined. Degree of zero polynomial is not defined. Now 12th question, that is given that additive inverse. So simply additive inverse is nothing but changing the symbols or changing the sign of a algebraic expression is called its additive inverse. For example, here question is given x plus 2. X plus 2 we need to change their signs according to the degrees and according to the terms. Here plus x will be minus x, plus 2 becomes minus 2. So minus x minus 2 will be the additive inverse. Minus x minus 2 will be the additive inverse of x plus 2. Okay, na? Right. Now 13th question. Additive inverse means just changing the sign of the expression. Okay. The sum of a square plus b square and a square minus b square. Addition is asking. A square plus b square, a square minus b square. Two polynomials are given. Their sum. Their sum means plus we should take. Plus b square minus b square can be cancelled. Then what are remaining? A square plus a square is 2a square. Therefore, the sum of a square plus b square and a square minus b square is nothing but 2a square. Okay, na? Yeah. The 13th is completed. 14th problem, L minus m into n. I am writing here 14th one. L minus m into n. That means binomial with monomial. Simply, it is looking like the distributive property. So, what is the distributive property? A into b plus is nothing but a into b plus a into c. So, let us try to multiply here. L into n, Ln minus m into n, Mn. So, after simplification or after multiplication, we will get the word or we will get the expression like Ln minus Mn will be our required answer. Okay, now. Right. Now, let us move on to the exercise problems. So, I am not going to tell each and every problem. If it is based on the concept, you can do it by your own, or any simplifications are there means I am going to explain here. Exercise 1 problem. Yeah, first one. The first problem is given that the degree of the polynomial. Degree of the polynomial. Identify the highest power in the given exponent. That is x power n. N is called degree of the polynomial. Check here. A into a naught x power n. What is the polynomial here? A x power n plus b x power n minus 1 plus and so on is given. This is a polynomial which is having a degree n, highest power n. So this is called nth degree polynomial. Nth degree polynomial and its degree is n. Let us go to the question number 2. Second question, degree of the polynomial. That is also you have just first divide it and find the answer. That is your option. Now third one also degree of the polynomial you can identify. But while you are observing here, the last second term is for x power minus 1. It is not a polynomial first of all. X to the power of minus 1 is given, but negative integers are not accepted as a polynomial. So it is not a polynomial. Next. So fourth one, substitute the value minus 1 in the given equation, you will get it. 0 of the polynomial same, it is equals to 0. Let us see the question number 5. The fifth question is given that, so 0 of the polynomial of x square minus 2x. X square minus 2x, 0 of the polynomial. So whenever to find the 0 of the polynomial, try to equals to 0. First two terms you can see the x is a common term. So take x minus 2 equal to 0. Okay, if I take x common, x into x square, x into 2, 2x. I have taken x as a common factor. Okay, now either of them can equal to 0. That means here x is equal to 0 or x minus 2 is equal to 0. Then only you will get the answer 0. Now minus 2 transpose as a plus sign. So therefore the answers are 0 and 2. Here x value 0 we got, here x value 2 we got. 0 and 2 are the zeros of the polynomial. Because it is quadratic polynomial, degree 2, it will get 2 zeros. Degree 3 means 3 zeros will get. Degree 4, 4 zeros will get. So based on the degree, that many zeros we will get. Zeros are root of the polynomial. Okay now? Yeah. So that's it for today children. Thank you one and all. Have a nice day. Bye bye.